Welcome back. We have talked about two types of descriptive research. One type we talked about was case studies. Case studies are very useful when we have very few cases, when we have a very few individuals with a particular characteristic. For example, at the beginning of the coronavirus pandemic, when we have just maybe 3 cases, 5 cases, this is a rare disease, we don't know much about it, we want to study it in great detail, then we do case studies. The same thing goes with HIV. At the beginning, in the early days of discovering the HIV infection, which leads to AIDS, we didn't have a lot of cases, very few cases, very rare cases. Only a few people appeared to have this kind of diseases. And then we have to study each individual really closely, really carefully, gather as much information as possible to understand the disease better. This is a case study. Another kind of research methodology, which is also descriptive, we discussed, was survey research. Survey research, in a sense, is almost the opposite to case studies. We can study many people at the same time with surveys. We design a questionnaire and administer the questionnaire to large numbers of people. These are the two descriptive research methodologies we have covered so far. There's still another type of descriptive research we need to talk about. This type of research is called naturalistic observations. Naturalistic observations. In this method, we observe individuals, people, and even animals in their natural environment. We don't have any interventions. We don't participate in what they are doing. We just observe them. We talked about this example already, and this example can be studied with naturalistic observations. I have a theory which says frustration causes increase in aggressive behavior. And I'm claiming that when people are frustrated, they're more likely to be aggressive. How do I find out whether this theory is supported by evidence or not? I can do a naturalistic observation. For example, I can make observations on football teams, and I can make observations on particularly those teams that really want to win really badly, but they are losing. They are frustrated. These players are frustrated in their goal achievement. They want to win really badly. The stronger their desire to win, the more frustrated they become when they lose. And I can observe during the game when they're losing or after the game after they have lost, whether these frustrated players display more aggressive behavior. And I'm observing them in real games. I'm observing them in real situation, in their natural environment. This would be a naturalistic observation. We cover 3 types of descriptive research: case studies, survey research, and naturalistic observations. Next, we're going to talk about correlation research or relational research. Correlation research and experimental research are very widely used in psychology. These are probably the two most widely used research methods in psychology. We talk about these two methods in comparison with each other. There are some advantages to correlation research and some drawbacks. On the other hand, there are some advantages to experimental research and some drawbacks. We start with a discussion of correlation research. Correlation means that there's a relation between two variables. It takes at least two variables to have a relation or relationship. In correlation research, we try to answer the question, how is variable X associated with variable Y? For example, is there an association between people's body weight and their height? Is there a correlation between how tall people are and how much they weigh? I think there is. Taller people tend to be heavier. So I'm claiming, or I'm proposing, there might be a positive correlation between how tall you are and how much you weigh. And another correlational question is, are animals with higher levels of testosterone tend to be more aggressive? I'm asking, is there a positive correlation between animals' levels of testosterone, this hormone, and their aggressiveness? I can also ask a correlation question that, are unpleasant living conditions, unpleasant living environments such as hot weather and poverty associated with increased aggression? I can focus on one variable. There are too many variables here in this statement. For example, I'm only interested in the relation between hot weather, between temperature, and aggressiveness. Is it true that the hotter the weather is, the more aggressive people become? Is there a positive correlation between hot weather and aggressiveness? And I can also investigate whether there's a correlation between poverty and aggressiveness. Poverty can be measured as income, people's annual income. Is there a correlation between how much money people make and how aggressive they are? These are correlation questions. On the other hand, experimental research is more involved. Experimental research tries to uncover causal relations between different variables. We are not only asking, is variable X related with variable Y? We are asking, does variable X cause variable Y to change? Does high levels of testosterone make people more aggressive? In this statement, I'm claiming a cause and effect relation. I'm asking, does high levels of testosterone cause people to display increased levels of aggressiveness? I can ask another causal question. Does unpleasant living conditions, such as hot weather, cause people to display increased aggressiveness? Again, I'm claiming that hot weather is a causal variable and it leads to increased aggressiveness as a result. This is a cause and effect relation. Only experimental research can uncover cause and effect relations between two variables. We will see why. A key issue in this part of the material is that we need to understand why correlation research does not tell you cause and effect relations between two variables, although it does tell you if whether there is a strong correlation or weak correlation, a positive correlation or negative correlation. It doesn't tell you cause and effect, but experimental research is able to tell you the cause and effect relation between two variables. Why? Why there is such a difference in the impact of experimental research and correlation research. This is a key point. Let's look at an example of a correlation research. I'm investigating the correlation between environmental temperature, basically hot weather, and aggressiveness. Aggressiveness is measured by a crime rate. How many crimes are recorded? How many fights are recorded in the city? There are different ways. There are basically two ways to represent a correlation. One way to represent a correlation is to use a graph. This graph is called a scatter plot. The scatter plot describes a two-dimensional space. You have an x-axis and you have a y-axis, horizontal y-axis and a vertical axis. Each axis represents a variable. I'm using the x-axis or the horizontal axis to represent temperature, and the vertical axis represents a city's crime rate, or the number of crimes recorded in the city. And let's see, I have these dots in the scatter plot. Each dot represents a city. You can see each city give me two numbers, give me two values. City A gives me a value on temperature, the annual temperature, the yearly average temperature. City A is in a very cold place, cold weather. The annual yearly average temperature is pretty low. And the crime rate of City A is also pretty low. Low number of crimes recorded. Each dot represents a city. It gives you two values. Say City B is another example from the data points. City B is kind of still lower in temperature, still cold in weather, and the crime rate or the number of crimes recorded still pretty low. And we also have some hot places, cities in hot weather. City C, you can see the weather, the temperature, annual temperature is pretty high, and the crime rate or the number of crimes recorded is large in numbers. So is City D. You plot maybe, you have 50 cities, so each city give you two numbers. You have a sample of 50 cities, maybe 100 cities. The larger the number, the larger the sample, the better data you get. And by plotting all the cities' values on the scatter plot, you can see a trend, or you can see a pattern. You can see that those cities with high temperatures tend to have larger numbers of crimes recorded. On the other hand, those cities with colder or lower temperatures tend to have less crimes recorded. This is a trend. And if this is indeed the case, you have a positive correlation. A positive correlation means as the value of one variable increases, the value of the other variable also increases. They increase in the same direction and decrease in the same direction. In a scatter plot, you can draw a line. Draw a straight line through all the dots, through all your data points. And this line, if you draw it properly, it's a best fitting line. It will be the line of best fit. The reason that it is called the best fitting line or line of best fit is that it really fits all the dots the best. Here I've drawn a line of best fit or best fitting line. By best fitting line, I mean that so you see all the dots have some distance from the line. Only a very few dots are actually on the line. And the best fitting line has the shortest combined distance from all the dots. Suppose you measure how far away each dot is from the best fitting line, and add them all up. The combined distance from all the dots to the best fitting line should be the shortest possible. This is the only best fitting line possible for the data points. Suppose I change the direction of the line a little bit. Suppose I kind of move this line a little bit. It's no longer the best fitting line. It's no longer, it doesn't fit all the dots the best now. Because this way, the dots, combined distance of all the dots will be not the smallest possible. This is an example of a positive correlation, and we can use a scatter plot to represent a positive correlation. What kind of conclusion can we draw based on this data? Based on this result of data analysis, what conclusion can we draw? Can we draw the conclusion that hot weather causes crimes to increase? Can we draw the conclusion that there's a causal relation between the two variables, temperature and crime rate? No. The answer is no. But why not? Why not? You see, these cities with hot weathers, they record more crimes than the cities with colder weathers. Isn't this the case? Doesn't that tell us that hot weather make people more aggressive and make a place have more crimes? Why? What is the reason that we cannot draw causal conclusion based on this data? One reason, is it possible that hot weather cause some place to have more crimes? Yes, indeed, it is one of the possibilities, but only one of the possibilities. Are there alternative explanations? Are there other possible causes? Yes. Can you think about, say, if you look at city C and city D, these two places, what other variables, what other reasons could cause these two cities to have more crimes? Maybe poverty. Maybe these two places are economically disadvantaged. Maybe these places have a lot of low-income families, low-income people, high unemployment rate. Maybe the number of police officers in the streets in these cities are small. Maybe these places have a lot of have a lot of, gang activities and dysfunctional families, single-parent families. All these factors could cause city D and city C to have a larger number of crimes. So weather is not the only possibility. The other possibilities are there and uncontrolled. You are comparing cities with a lot of differences. You are comparing different cities with differences in many different dimensions. Temperature is only one of the dimensions. They vary. So if you find out that these different cities have different crime rates, you cannot confidently trace the difference in crime back only to temperature. There are other possibilities. There are alternative explanations. You have no control over these alternative explanations, like poverty, like number of police in the street. This is the limit of a correlation research. In the correlation research, you just measure, you just observe and measure your subjects. In this case, your subjects are the cities. For each city, you just observe the temperature and observe the number of crimes. So you don't have any control over all the other variables. This is one drawback of correlation research. Now let's look at another example. When you are studying different cities, you have no control over in how many aspects the cities differ from each other. They may differ from all kinds of aspects. What if you are just study one city? For example, you just study one small town. Menominee in Wisconsin, and how about that? Suppose you study just one place and you record the daily temperature over the year. Daily temperature varies in the same place. In winter time, for example, you study in the winter time. In winter time, the daily temperature is going to be low. And then in spring, the temperature increases. And then in summertime, it gets warmer and warmer, get really warm. And then you also record the crimes recorded in each day at the police department. So on this scatter plot, the vertical axis is the daily temperature of the city. The horizontal axis is the daily temperature of the city. This is x-axis. The vertical axis, the y-axis, is the number of crimes recorded on each day. In the space, each dot represents a day in the year. A day in the year, for each day you record two values. One value is the daily temperature of that day, and then the second value is how many cases, crimes recorded on that day. And you can see a trend. Suppose you find a positive correlation between daily temperature and number of crimes on that particular day. Now, can you draw the causal conclusion that hot weather causes people to be short-tempered? Hot weather causes people to be hot-tempered, so there's more fights, more crimes. Can you draw the causal conclusion? Now, while you have kept the different aspects of differences between different cities constant, you don't study different cities. Different cities vary too much. They differ too much. You just study one place. You just study one place on different days of the year. And this place, the population is pretty constant. They don't differ from each other that much on a day-to-day basis, so you are studying the same people. Now, can you draw the causal conclusion that it is hot weather that causes people to be more violent and commit more crimes? The answer is still no. Still no. There are still uncontrolled variables in the data. Although you are studying the same people, the same city, you see each day is different in many aspects from another day. You see that in wintertime, the temperature is low and the less number of crimes. Maybe, there is indeed a relation between number of crimes and daily temperature. But are there alternative explanations? Are there other factors that might be impacted or implicated? Yeah, maybe, in cold weather, people stay inside. They don't go out that much. It's too cold to go out. So they don't mingle. People don't run into each other as often. But as the weather warms up, it's sunny outside, the day gets longer and gets warmer, so people go out more. The bars are open, and people start to run into each other. Tough guys start to run into each other at bars, and after a few drinks, fights get started. So maybe it's not only temperature. Temperature does correlate with number of crimes. Maybe it's how much people go out, how many opportunities people have in running into each other, how much contact people have. All these variables from day to day are uncontrolled. You don't have control over these variables. This drives home the point that correlation research does not tell you about cause and effect. Let's understand correlation research some more. A correlation can be strong or weak, and a correlation can be a positive correlation or negative correlation. One way to represent correlation is using a scatter plot. You see, on a scatter plot, if you have dots, if you have the cases all pretty close to the best fitting line, all kind of clustering around the best fitting line, you usually have a strong correlation. And another way to represent correlation is to use a number, the correlation coefficient, the Pearson correlation coefficient. And you see in this graph, I have a correlation coefficient that equals to 0.90. That is a pretty strong correlation. Strong correlation in number and the strong correlation indicated in the scatter plot. The closer to positive one, the stronger the correlation. In terms of positive correlation, positive 1 is the strongest positive correlation. In what conditions do you have a correlation coefficient that is equal to positive 1? You are measuring the same thing. You are measuring basically the same variable, just in different scales. For example, you measure the temperature in Fahrenheit and in Celsius, and if you plot your data points on a scatter plot, it's going to be on a line. It's going to be on a straight line, and this is the best fitting line. All the dots are going to be on the best fitting line. This means that suppose you know right now the temperature in Fahrenheit in this room is 60 degrees. Can you figure out exactly what is the temperature in Celsius degrees? Yeah, there's a 1-to-1 correspondence between these two variables. These two variables measure the same thing. They measure the heat, the amount of heat in the room, in the environment, in the air. So there's a one-to-one correlation, correspondence. The stronger the correlation, the more precisely you can predict the value of one variable if you know the value of the other variable. If you know the value of on Fahrenheit, you can predict the value on Celsius degrees. This is the strongest possible positive correlation. Look at these two correlations. Which one is stronger? The one on the left or the one on the right? The one on the left is stronger. The one on the right is a little bit weaker than +1. Because although the dots are all clustered around the best fitting line, but they are not on the best fitting line. So you would expect the correlation coefficient of the figure on the right hand to be a little bit less than +1, but still pretty strong. This is really weak correlation. What a weak correlation look like on a scatter plot. You don't see a particular pattern. You see the dots are all over the places. There's not too much a correlation between the x-axis and the y-axis. Here, the x-axis, the horizontal axis, represent the variable of height. Some people are taller, some people are shorter, some people are 6 foot and above, some people are 5 foot, etc. And then the vertical axis represents a depression, how depressed people are. So some people are not depressed, some people are pretty high in depression. You see a weak correlation because the tall people, some of them are high in depression, some are low in depression, some are in the middle, and then the short people, they also might be high in depression or low in depression. In other words, if you know a person's height, if you know how tall the person is, it's very difficult for you to predict how likely this person is going to be depressed or non-depressed. The correlation coefficient for this data is negative 0.23. It's kind of weak. Another example of a negative correlation. Suppose you are studying people's fear and anxiety. Suppose you are interested in why some people have a fear of snakes, even harmless snakes would really scare them. And you have a hypothesis that says fear has a negative correlation with confidence, or what we call self-efficacy in research. You have to measure two variables. In order to do this correlation research, you have to select a group of subjects, you have your sample, and for each person in your sample, you measure two values. You measure their value on self-confidence or self-efficacy, and you measure their value on fear of snakes. You can have a simple survey research, questionnaire research. On one variable, you would ask them to indicate how confident you are that you can successfully handle a harmless snake. Suppose if I gave you a snake to handle harmless, how confident you are that you can successfully handle this snake? Touch it, pat it, etc. Give me a number from 1 to 7. 7 means you are highly confident. You can do that. 1 means you are not confident at all. And then 4, 5 represent somewhat confident. This is one variable. Another variable would be how much fear do you have? So another variable would be that you show him the snake. You show the subject the snake, and you ask how afraid you are right now, how fearful you are right now. 7 means extremely fearful. I'm freaking out. 1 means I'm not fearful at all. I'm okay. And then 4 and 5 means somewhat fearful. You measure your sample. Each person would give you 2 numbers, and you plot the numbers, the data on the scatter plot, and you see a negative correlation. In this scatter plot, each red dot represents a person. Each person gave you 2 values. On the horizontal axis, it's self-efficacy, how confident they are. And then on the vertical axis, it's their fearfulness, how fearful they are. You see, those people, those individuals who are highly confident that they can handle the snake, they tend to show less fear. Their fear value is low. On the other hand, those individuals who are low in self-efficacy, not confident that they can handle the snake, their fearfulness is pretty high. So as the self-efficacy go up, fear goes down. This is a negative correlation. Of course, this is made-up data, not real data. I did the calculation, R equals negative 0.90. Very strong negative correlation. This is the strongest possible negative correlation, -1. -1 is the strongest possible negative correlation, while +1 is the strongest possible positive correlation. Under what conditions do you have a perfect negative correlation? In a perfect negative correlation, you are also measuring pretty much the same thing, same variable. For example, you have an exam, the full score is 100 points. If you know that you get 70, do you know how many points you lost? Yeah, you lost 30 points. Suppose you know that your score is 90. Do you know how many points you lost? Yeah, you lost 10 points. As the value of one variable increases, the value on the other variable decreases, and there's a 1-to-1 correspondence. This is perfect negative correlation. Between these 2 correlations, which one is stronger? The one on the right is stronger. Let's look at another example. The level of testosterone differs from person to person, even within the same gender. Aggressiveness also differs from person to person within the same gender. You have 2 variables, aggressiveness and testosterone. Well, are these two variables correlated? Do you expect a positive correlation or negative correlation? Do you expect a strong correlation or a weak correlation? So in order to complete this study, you need a sample. You need a sample of individuals, and you measure them on 2 variables. You measure each individual's testosterone level, and you measure his or her aggressive level. For example, you can take blood. You can use prisoners in the prison as your sample. And for each prisoner, you take the blood sample and measure testosterone level. And then you can look at the records of each prisoner and find out over the last week, over the last month, how many times the prisoner fought with other inmates. And then you do the calculation. Suppose you find R equals 0.56. What does this mean? This means you have a positive correlation. And this positive correlation is kind of strong. It's pretty strong, 0.58. Let's summarize a little bit. Correlation. Correlation coefficients, the range of correlation coefficients runs from -1 to +1. Both -1 and +1 are really extremely strong correlations. The closer the correlation coefficients to +1 or -1, the stronger the correlation. They're just in different directions, positive versus negative. And the weakest possible correlation coefficient is 0. The closer the correlation coefficient to 0, the weaker the correlation between the two variables. Look at these three correlations. Correlation between testosterone and aggression is R equals positive 0.56. Correlation between hours spent watching violent TV and aggression is positive 0.6. Correlation between years of education and aggression is negative 0.65. So as people spend more years in school, their aggressiveness seems to decrease. There's a negative correlation between year of education and aggression. Which correlation is the strongest? Well, the last one, R equals negative 0.65. This is a strong negative correlation, stronger than the other two. You look at the absolute value of the correlation coefficient and disregard the sign to find out how strong the correlation is. How do we make interpretations of correlation research? Suppose you find a correlation between how many hours people spend watching violent TV programs and aggression is strong and positive. R equals 0.6. What are the possible explanations of this data? What are the possible interpretations from this statistics? I have three options. Number one, watching violent TV causes aggression. Is this possible? Based on what you have found in your research, would this be possible? Yeah, watching violent TV could cause aggression. But are there other possibilities? Could it also be that being aggressive causes some people to watch a lot of violent TV as an outlet? Some people are more aggressive, and that's why they take interest in aggressive behavior. And then another third possibility that a third factor other than TV and aggression is causing both watching violent TV and aggression. So something else is making some people watch a lot of violent TV and being violent. An example would be frustration, stress from unemployment, or bad marriage. Frustration could cause aggression, and frustration could cause people to watch a lot of nonsense violent TV programs. All these alternatives are possible. You don't know which one is the cause. So From correlation research, you can conclude that there might be a positive or negative correlation, strong or weak correlation, but you cannot draw causal conclusion between the two variables. Still another example on correlation research. Your research question is about the relation between overwork and marriage quality of marital relations. You are suspecting that those people who work long hours tend to have poor marriages. In other words, there's a negative correlation between how many hours you work per week and your marital satisfaction, your satisfaction with your marriage. So you do the research. You survey a sample of people. For each person, you measure two values. One value is work hours. How many hours do you work per week? Some people work long hours, 70 hours a week, and that's a lot of work. Some people work only part-time, only 30 hours a week. And then you also measure each person's satisfaction with their marriage. How happy are you with your marriage? 0 to, say, 12. 0 means, no, I'm not happy at all. I want a divorce. But 12 means I'm really happy. This is the person I want to spend the rest of my life with. Suppose you find this pattern. This is negative correlation. People who work long hours tend to have a low satisfaction with their marriage. What kind of interpretation can you draw? Can you make on the data? What kind of conclusion can you draw? Is it possible that long work hours make people to have a low satisfaction with their marriage? That is a possibility, definitely. Well, if somebody is not spending any time with their spouse, instead they're working all the time, of course, the marriage quality will suffer, less satisfying. That's one possibility only. Could it was also possible that it's poor marriage, it's a bad marriage, cause people to work more? That is another possibility. You cannot rule this out. Maybe the family life is so stressful, so unsatisfying, you would rather stay at work. Working is an escape from poor marriage. That is also a possibility. Could something else, could a third factor cause some people to work long hours and have less satisfying relations? Yeah, that's another possibility. You can think of poverty. Poverty may make the family relations stressful. People start blaming each other for family difficulties, financial difficulties, and then people have to work long hours, maybe take 2 jobs to make ends meet. All these possibilities cannot be ruled out with correlation research. So in correlation research, you cannot draw causal relations between two variables. Although you can see there's a negative correlation between work hours and marital satisfaction. Let's take a break.